Hello everyone, and welcome back to Technically Unsure, where I'm not really sure what I'm doing technically. Today we are going to review an amazing board from Asus. Specifically, of course, I'm talking about the Tinker Board 3N. So this is how it arrived. We are going to open it and check it out. So this board actually packs a punch. It does have a Rockchip RK3568 SoC, and it contains basically 64-bit quad-core ARM Cortex-A55, which is also, as you may know, it's built on ARM v8 architecture. As for the GPU that is in the SoC, it does have the ARM Mali-G52, the 2EE variant. I think the boost clock is 820 megahertz, something like that, for the GPU. They provide two types of operating systems, which officially, of course, you can tinker and tweak around, but I prepared both of them for you to see. They support Android 12 and Debian 11, which I prepared before this, so we are going to install these two, just run in these two on the board. And I will also put the link below for the Tinker OS, so you can download it in there. Anyway, let's take a closer look at the board. This is what you get. I have never opened it before, so we are going to do it together. There is this user guide in various different languages. Then I think, yeah, that's a pad. That's the power supply. 12 volt and 2 amps, so that's a lot of power, honestly. Board itself, which we are going to open, oh, it's not sealed or anything. This is the board. It's beautiful, honestly. Yeah, we are going to talk about all the I/O. So here is the I/O side, and these are a lot of pins and programmable, addressable GPIO and everything. More stuff in here, power, and so on. So we're going to talk about that, and a huge, massive heatsink in the back. It gets toasty. Oh yeah, there is also, I see, like SD card and SIM card slot. Oh yeah, so this is probably an antenna, so we're going to check that out. But on the box itself, it says Tinker Board. I'm not sure if it is on focus. Yeah, Tinker Board 3N 4G and 32 gig. Oh yeah, so 4G 32 gig version, that's what I bought. Let's take a closer look at the board. So from what I know, they were saying 4 inches by 4 inches, like 100 millimeter. So let me grab a ruler actually to confirm that. So yep, that's about it. So 4 inches by, yeah, it's less than 4 inches, but okay, yeah. Yeah, centimeter wise, that's also correct. It's 10.5. Yeah, it's 10.5. It does have 2 gigabit Ethernet ports. That's impressive, honestly. 2 on this tiny board. 2 gigabit Ethernet ports are here. Let me make sure. Also, I will show it in the other camera in close proximity, so you can see it in there. 2 gigabit Ethernet ports, and then 1 sideway full HDMI port, and there is a USB-C port in here. And by the way, this HDMI port is CEC ready. In case you're wondering what CEC is, basically it stands for Consumer Electronics Control, and it's HDMI feature, right? So it allows you to control HDMI connected devices with a single remote. Like, let's say if you connect this to a TV, when you turn on your TV, this will turn on. When you turn off your TV, this will turn off. Something like, you see it on the, TV, Fire TV, Amazon Fire TV, or PlayStation, and so on. So they have that in this. Yeah, so version of it, I believe, is HDMI 2.0. From what I recall, it's HDMI 2.0. We have a USB-C 3.2 Gen 1, I believe, and then we have 2 USB-A ports, but these are also 3.2 Gen 1 ports. This is the 3.5 millimeter audio jack, So this one is audio, and this one is the speaker out. So this is probably audio as well. Yeah. And this next one is actually a USB 2 header. So you can connect potentially custom devices to this. It does have a USB 2 header in here. If you don't want to use these ports, you can use it in this one. This is slower, obviously, USB 2, but yeah, you can use this as well. And we talked about the 3.5 millimeter. We talked about this. We continue. So this is RS-232 422 485 COM port. Sorry, this one. So this one, I'm pointing to it. Yeah, this one. And then the next one is actually a GPIO pin. So you can use this to program stuff, and the GPIO pinouts, I printed it. We are going to use that. These are the pinouts, and it's a 14 pin GPIO and 5 pin volts, ground pin, and multiple GPIOs, and so on. So UART as well, and SPI, and so on. So yeah, that's the GPIO pins, 14 of them. And then next to it is the I2C. Oh, by the way, as I was saying, in the GPIO there is one I2C bus, 2 UART, and one SPI bus, and SPDIF, and 4 PWM, so and ADCs as well. Very powerful. And then there is the next one is COM, basically RS-232 in here, and then the CAN bus, and yeah, there is also IR headers in here. So this is for the infrared IR header. And the last one on here is the CAN bus. So this is the CAN bus, this is IR, and 3 COM ports, which is RS-232, 422, 485, RS-232 again. So yeah, these are the communication ports, yeah, on the side. And yeah, nothing else in here, I believe. And flipping the board over once again from left to right. In this side, we have LVDS connector, which basically you can connect to LCD screens, right? And there is LCD backlight connector, and the barrel jack for power, which it says on the datasheet that it allows up to 24 volts. And what we get in the box, as I showed you, is the 12 volt and 2 amps. So this is what you get. Should be more than enough. There's a debug port in here. In this side, the last side, there is this one, I believe. Yeah, it says right there PoE. Yeah. So this 4 pins sticking out in here is PoE ports. So you can power it through PoE, but yeah, it's PoE headers. We talked about that one, and that's right next to Ethernet ports as well. Oh, and in the middle, as you can see, this small one is M.2. This is the M.2 E key 2230, and used mainly for the Wi-Fi 5 and 6 and Bluetooth module. So this is PCIe 2. And then this on top of it right here, which I'm gonna try, is 3042, 3052. It can be used for a 4G or 5G module. It can be used for SSD module, and it's a PCIe 3.0. Yeah, there is the SD card slot and nano SIM card slots. So you can put the SIM card in here, and if you install a 4G or 5G module in here, you will be able to insert SIM card here and use it that way. And there's also CPU fan header in here. If you don't want this giant heatsink, you can probably install a fan. Yeah, so I'm just going to use it as is without changing anything. I believe that pretty much covers it. I have prepared, as I said, 2 SD cards, but I will show you in the link on the screen, and I will put in the video description where you can download the images as well, Tinker OS images. I got Debian 11, and I got the which is the white one, and I got the Android 12 on this black SD card. We will try both of them. We will try both of these SD cards, and we'll see how it goes. Okay, we are back. So I have the board ready. I brought also the Raspberry Pi with the SSD installed on it, which boots from the SSD. We're going to use that as a base for benchmark. I connected the Ethernet cable, as you can see here, right? So Ethernet cable, HDMI. I put the two antennas here for the Wi-Fi. We are going to test that later. I also connected the first GPIO and third GPIO pin, which based on the what's written on the GPIO documentation, the first one is 5 volt and the second one is ground. And I'm going to connect a multimeter to confirm that. So all that being said, let's power it up and see how it goes. Let's power it up. Okay. All right, so Tinker Board. So far so good. Yeah, so as you can see, the first pin is as you can see here, first pin is 5 volt and third pin underneath is ground. So to confirm that, I am going to do a multimeter test. So let's connect the VCC and the ground and go to this. Yes, as you can see, we are getting the 5 volt. Okay, so the GPIO's 5 volt is good, stable. So I can remove this for now, turn off the multimeter. We're good for now. So we also identified the first and the third pin. I just wanted to confirm it's not the other way around. So it's the side away from GPIO, from the I/O ports, so USB and so on. So it's the other side, that's the first pin on the left. Okay, so let's load up the terminal, and first thing obviously NeoFetch. Yeah, so by the way, as you noticed, I didn't enter any credentials, any password, but I read it somewhere that the default username and password is Linaro. So whatever you see here, that's the username and the password. And this user is also sudo capable and does have sudo privileges. So Asus Tinker Board 3N, Debian 11 Bullseye, and XFCE desktop environment right now, and CPU 1.9 gigahertz, and the memory is 4 gig. Yes, so I got the 4 gig version for the memory. There is 8 gig version of it, which is the plus one. I didn't get that one. That was going to be shipped later, so I got this one that was going to arrive faster. So let's do some quick benchmarks, right? First thing I'm going to do is a very quick sysbench. Let's do 4 threads and the CPU and run. Okay. Wow. That's good. That's good. 3,000, almost 4,000. Okay, events per second. And let's do a quick 7Z benchmark. Okay, so in total, what we are getting is here, right here. So average speed looks like 2.4 is that, I think 2.4 is the average. 2.6, okay, 2.6 is the average. Okay, and very quickly a stress NG as well. Doing it again. Okay, and here is the result for the CPU, and I just want to make sure is it hot? not really. I'm touching the heat sink and yeah, no, it's not hot. It's not toasty. All good in here. Okay, one more thing. I want to confirm that the wire Ethernet connection is actually fast, and it is actually 1 gigabit. So let's do iPerf3 and let's do it 50. And someone in one of my videos told me about the bidirectional, so thank you for that, and we're going to do that. And all right, well, not bad, not great, it's all right.
Not too bad.
Not too bad.
720 megabit per second. Okay, was expecting more, but that's okay, that's fine. All right, so we tested the CPU with multiple apps. I also came across one thing on GitHub that is called SBC bench. So this one takes a long time. I will try to run this and maybe publish the results somewhere and share it in the comment section maybe. It takes like 20 minutes or so to do the benchmark. What I'm going to do is I'm going to turn it off and try to install this on it, and I'm going to try to boot from this if possible. I didn't check the documentation, if any, but I'm going to try it. And if I was able to do that, I will let you know. I will be right back. First, let me just install this in there. Okay, so before I switch to SSD stuff, I just remembered I bought the 32 gig version of this board. So I want to try to use the internal SSD to do that. So what you can do is you can come to this URL, tinker-board.asus.com, download the image, and you can use the Tinker Board 3N version, obviously. And I downloaded this, right? So it gives you an .img file, and then I'm going to show you how you can write that to the SSD. So what you can do is let me show you. So we can go to the downloads folder, and here is the file, right? The img file. And if you do a sudo, let's switch to sudo. So if I do an fdisk, you're gonna see that this is the 32 gig internal flash of the chip of the device, right? And this is the SD card that I'm booting from. So what you can do is you can say ddif is this Tinker Board, the img file, of output file is this one, and binary size you can go 1 meg or whatever. So let this copy that img file to internal SSD. While that's running, I just noticed something. I just want to show you that if you even run 1080p at 60 frames per second, it is constantly dropping frames. So I just want to show you this. Watch. Yeah, so this is stock SSD, remember, and stock image. I downloaded from Tinker Board. I'm assuming all the drivers are installed, everything is installed, and it looks like it is installed. So it's playing this, but it is dropping a lot of frames. So this is at 1080p. So 4K, don't even think about it, but let's try. I just want to show you. So 4K at 60 FPS. I believe it's just constantly dropping frames, but let me show you. And I'm going to do FF play as well, just in case. Okay. Yeah, that's what I'm talking about. It's very, very bad. Can't play that. So I just also wanted to show you two more things before switching. Okay, so the copy is over already. That's not much, right? 3 gig, it was fast. So next I'm going to turn it off and boot from the internal disk. And before I do that, a couple more things I want to show you. The default browser that comes with it, when you execute it, this is what it shows you. It's the configured to run with no sandbox. So usually you do it when you're running it at root, but anyway, that's one insecure thing in there. Another thing I wanted to show you was FF Play. So if I do FF Play and on this video that I downloaded 4K, you will see. Okay, I also saw 2 errors. Load driver Rockchip failed. So it is failing to load the driver for Rockchip. Okay, but yeah, as you can see, it's just dropping frames. It is playing very slowly, but it is dropping a lot of frames. It's dropping a lot of frames. So yeah, doesn't look good. So yeah, it's playing, but as I said, very badly. So let me close this. I will show you another example. Let me show you the video samples once. So let's try a 1080p 30 frames per second, this one. So FF Play, actually let's straight go to this file, right? Yeah, this one plays better, still not that good, but yeah, it's also dropping a lot of frames. Yeah, it's not good, doesn't look good. And I have to investigate. I can't believe it, this error. I have to investigate this, but you know, this is the default SD image that they are providing. I downloaded off of Asus, and now I just burned it into the internal 32 gig MMC flash chip, right? So now I'm going to reboot, shut it down. So let's do that, shut down. Let's do that, shut down right here. Shutdown is fast actually. So what I'm going to do is I'm going to now power it off and remove the remove the SD card, and I'm going to power it on. Let's see what happens. Yep, as you can see, it is booting, and now it is booting from the internal flash chip, 32 gig. So speed-wise, I believe it is a little bit faster. I'm not sure yet. Yeah, boot time, I believe it's same, but first boot always takes a little bit longer, remember that. It's also expanding the file system and all that. Yeah, okay. Yeah. Okay, now I have to install everything together from scratch because it's brand new, right? So another problem, not problem, I just wanted to show you. So there is no nano by default, right? So what I wanted to show you is, let's go here. So if we do etc apt sources.list, you're going to see that again, it ships with 2 Chinese Debian mirrors. So if you attempt to do apt update, unfortunately it's going to take forever, especially if you're not in China. So let's edit that out, and now apt update should be faster, hopefully. Yep, as you see, that took a long time just to do apt update, but it is the first time. After that it picks up. So if we install the stuff that I installed before, let me see how long it takes. I am going to say, at least so far, I don't know, maybe it will pick up eventually, but SD card one was faster. And I have to investigate that FF Play error on the Rockchips. And I believe NeoFetch also wasn't showing anything on the GPU. Let's see. Okay, that took a long time, but I believe it's just for the first time. So yeah, there is nothing on the GPU in here. And the resolution is small, so I'm not sure, something is missing. Anyway, I will let it upgrade and see and do a reboot. Actually, I did that. Actually, I don't think this is going to do anything. I did that on the SD card one that we were using. I did the dist upgrade on that, and that FFmpeg test that you saw that I did while I was on the SD card, it was already up to date on all the packages, and I rebooted and everything. So yeah, that's no excuse. I don't know. That's how they are shipping it, and the GPU was very underwhelming. Hopefully it was using GPU at all. So now what I'm going to do is I'm going to try with the Android image and see how the Android image behaves, and hopefully we will get a better performance with playing videos in there, and maybe even some emulation. So let me actually I have it downloaded. I will boot from this Android SD card and see how it goes. We don't need this, I'm not going to use this, so breaking it. All right, we'll be right back. Okay, so before we try the Android stuff, I just wanted to show you quickly some more information that I just figured out. If we do this, run this command, right, we are trying to check the devices, platform, and look for anything that does have GPU in it. We are going to see, if we scroll up, you're going to see that this is the address, and there is a GPU device. So if we do now ls on that and tap, so you're going to see there is a GPU info file in there that I can call. So if I do a cat on that, you're going to see that there's a Mali-G52 GPU. So it is there, it is visible, it is loaded. It's just maybe those apps does not support that chip, does not use or leverage that chip, and that's why we're getting that terrible performance. Well, it is what it is. This is the official image. I ran the official browser that was installed in there, and you saw the results. So I also went out and did a git clone to the GL Mark II repo and built it. It took a while, like 10 minutes I guess, and it's done. Now I just want to show you how it does. So once you run it, yeah, so it is rendering, and this one is using that GPU. So okay, so we are done with the tests, and GL Mark score of 22. And the frame per second is 25 usually, around that, yeah, 5, 25, 12. Not great, not bad, not great, but yeah, it was the 4K resolution, just so you know. And as you can see here, we're definitely using that GPU. So there is no question about driver or anything like that. With the GL Mark, I was able to leverage the GPU. So these are the results with that GPU, and this is the version of the GL Mark. So you can see everything in here from my command all the way to the results are in here. So that's the result, just so you know. Yeah, so I showed you the GPU and I showed you the GL Mark result. We already saw the CPU benchmark results. It's now only time to try the Android. So what I did was I just downloaded the Android, and I did a DD onto the internal 32 gig storage, right? So I will just shut this one down. I'm gonna say it's really fast and shut down. Yeah, just see that's already done. So let me remove the SD card and boot. Okay. Okay. Yeah, so just so you know, literally I just did DDIF, the Android image, OF, the device name. which was the first one, the one with 0, the MM something 0. So you can do that, figure it out by doing fdisk-L, see the list of the storage devices. Obviously the bigger one going to be your SD card. There you go, we're in. Is this 12? It said Android 12. Okay, let's go to the settings. Oh yeah, more like it now. Okay, let's go about. Yep, Tinker Board 3N and Android 12. Beautiful. Let's be a developer. And this is great, honestly. It just worked out of box. And yeah. So this is a lot more smoother from the other one, and I'm assuming it is using and leveraging the GPU on this one. So let's see what we can do in here. There are default tools. These are the default apps that are installed in here, and looks like it doesn't have the Google Play Store. So the Google, yeah, it doesn't have the Google apps in here. Tinker Config, that's an app that they developed. Yeah, okay. Use the taskbar to switch the apps, we know that. Drag to the side to use 2 apps at once. Oh, okay. Touch and hold to touch and hold, touch what? Okay. That was more like a demo than a config, right? That was it? Oh no, there is it. Okay. So, the interface overlay, whitelisted app, boot logo, and power management. What is in here? Yeah, so it detected the yeah, so Mali-G52. So Android detected it at 200 megahertz. I thought it's going to be 800. Okay, yeah. So I'm sorry. So 800 megahertz is the max frequency, minimum is 200. So everything is right. Yeah, and also it's even reading the temperature sensor. So Android so far was a lot more smoother experience. Out of box, everything is a lot faster. CPU is also 36 and 1.4, and looks great. Yeah, max frequency is almost 2 gigahertz. That's good. That's good. Yeah, this is a lot better. And in terms of interface, yeah, UART. Oh wow. Okay. Yeah, this is nice. I haven't seen it before. If you have seen it, I haven't. So this is, you can do UART stuff from here, PWM stuff in here. Yeah, this is impressive. Okay, you can do that in here. I2C, UART. Okay, that's nice. And what is overlay? Okay, so that's for the other connector, LVDS. This is what we were talking about. I hope you can see it on the camera. This connection right here. So this is the LVDS, and this is the backlight. So it's talking about that if you connect it to a screen, I'm assuming. I didn't purchase a screen with it, so that you can try that with EDP as well. So there is EDP too. Okay, and whitelist app. That's like application whitelisting, blacklisting thing, I guess. Okay, nothing special. And power management, we checked that, and boot logo. Oh yeah, oh, it lets you change that. That's amazing. Okay, so this is, yeah, so far what I'm gonna say is the Android experience is much more smoother, easier, straightforward than the Debian 11 one. It was okay, Debian 11 as well. It's just the GPU thing is shaking there. It wasn't really working. The other thing I wanted to check was in the settings. So let's go to the settings, the connection. I just want to see if there is an Ethernet connection in here. I believe there is. To switch networks, disconnect Ethernet. Okay, I don't want to disconnect the Ethernet. Airplane mode. Oh, Ethernet is here. Okay, that's the problem number one. It did not get IP address from my DHCP server. Maybe I need to remove, and oh, what happened? Maybe the second one works. I don't know. Let's try it. I will plug back in. I can see there is a light that's on. It's not flashing, but it's on. Let's go back maybe. Okay. That's, I guess the INP should be capital in there, but it's fine. Yeah, it's not working. Okay, let's try the other port, maybe. Doesn't matter. Yeah, as you can see in the camera, hope you can see it. Let me show you. Yeah, you see the light is on and it's blinking. Oh, there you go, there you go. Okay. As you can see on the screen. So, okay, just so you know then, if you are using the Android image on this Tinker Board, if you're using the Tinker Board, you need to use this port for Ethernet. That one is not working somehow. So just so you know, that's a point to take note. Okay, now we are connected to the internet. That's also nice. So the Ethernet is working. The storage, yeah, 32 gig version. That's what I bought. You can also use the SD card. Well, you know what? Let's try this one. Since we are not using it, I just want to see if it is going to mount it, and then we can access the file in it. Okay. Hot plug. All right. So let's go to the files. Okay, so far no sign of SD. All right, but it is working. Is there any file in here? Good, it's clean. Sometimes you get these boards and they come with a lot of garbage in it. Some, like, they forget to delete their stuff. But this is good, this is good. Just want to make sure that I plugged in correctly. Yeah, I did. So yeah, its SD card is not showing up here. So also, just so you know, if you do that, in the Android at least, it's not mounting, at least automatically, it's not mounting the SD card. If I reboot it, maybe it will show up in there. So power off is here. Video, it's just a video player. Yeah, it's empty. So I'm gonna put some files in here and try to play 4K video and get some browser so we can do some benchmarking. I will be right back. Okay, so I figured it out and I was able to actually install the YouTube and Chrome, but it was tricky. And I just want to show you so you don't have to struggle to figure this out. So what I did was, this is just my method, full disclosure. You can do differently, obviously, but here's what I did. So let me show you. Okay, so what I did was I went to this website, APK Mirror, and I was able to download the variants which had for YouTube and for Chrome, the one that had ARM-64 V8, right? Do you remember that's the CPU that we are using here? So make sure you download a variant that, like, you go here and then it will list all the variants. So not the V7, this one, V64 V8. So I downloaded the APK, and when you download the APK, you get basically APKM file. So what you can do is you can right click and using 7-zip extract that, and you're gonna get these folders and it's gonna have a lot of files in it. So this one is YouTube, it actually has 2 APK files, and this one has a lot. So this is Chrome, it does have, this is split APK, right? So that's the Android thing. So this is bundle, and anyway, we're not gonna go there. So what you do is you just do this. ADB install multiple ***.apk, and I did that twice. So once for Chrome, once for the YouTube, just so you know that. So that was my method, and you can come up with other. Oh, by the way, that's how I did that with the you know, this USB debugging. Remember, I enabled the Android developer tools, and this is I did it via the USB debugging. So connect the USB to your USB-C port in your Tinker Board right here in the USB-C port, and that will act as a USB debugging. So I was able to do USB debugging and install the applications directly from my computer using the ADB. If you want to do ADB through the network, it doesn't work with the Ethernet. You can do it with Wi-Fi. I didn't want to go there, just did it with USB. So you can do it with ADB through wireless, or you can do it with ADB with a cable, or you can come up with other alternative methods such as SD cards and moving files around. But I didn't go there, it's faster. That being said, let's go back to the screen, the Android, right? Now let's open up a YouTube app. Yeah, that's what I'm talking about. It's a lot much faster. Let's search for a 4K demo video. And maybe this one. Okay, so we are doing 1080p and there is 0 frames dropped. That's amazing. And now let's switch. Oh, that was 720, not 1080. Yeah, that was 720, no. So let's slowly go up. So 1080p. Let's do it 1080p. And it is 1080p at 30 frames per second, no frames dropped. Let's do 4040, 1440, 30 frames per second. So far, no frames dropped. Looking good. Amazing. Okay. Now, oh, 1 frame, that doesn't matter. Now let's do a 4K finally. Let's see how it does. That's what I'm talking about. That's more like it. That's awesome. Okay, so as you can see, it can play a 4K 30 FPS, doesn't matter. 4K video, 0 frames dropped. So overall, as I said also earlier, Android experience was a lot more smoother, and yeah, things are much better looking in the Android version. Debian one needs some work. Obviously, it's not doing a great job. So I also want to confirm that the Chrome is working. I just installed it, but let's see. Yeah, it won't run with yeah, without that Chrome services. Google services, sorry. Oh, it complained, but it ran. Okay, that's good. And do you think we will get the same performance in the Chrome browser? We should. Overall, the GPU is working fine, right? 60 FPS one here. Okay, you're not supposed to do this, but yeah. Anyway, Chrome is working fine, and the YouTube also working fine. It's playing 4K videos, no frames drop. Everything is much better here in the Android version. I am going to let me see if I can find anything more interesting. Otherwise, we are gonna call it a day and wrap up this video. I'll be right back. Okay, so we are back. I did something. So I connected this 8-bit controller to the USB port, and what I did was I installed RetroArch just for fun. I just wanted to see how it does. So let's try a single, the Dreamcast game. I loaded it here. I copied over from my storage, and I did it through USB. So I did it through USB debugging through that same way how I installed the APK files. So here you can see the frames, FPS, and resolution, and all that data right on the screen. So just kind of seems smooth, playable, totally. And let's see. Yeah, 30 frames, and it's using the GL. Okay, so it's working. Okay, not bad. That's good. Yeah, so I just wanted to show you that this also works and you can play games on it as well. The resolution and you know, renders and frame rate and everything is on the screen. Yeah, totally playable, and I'm going to stop that. Yeah, so RetroArch is working for YouTube, is working, ADB connection is working. Overall, I'm gonna say the Android experience is a lot smoother. So let me see if I can find anything else, and we will take it from there. Okay, I wanted to show you one more thing before leaving. So this is the Tinker Board 3N GitHub page, and this is the URL that, as you can see on the screen, and I searched for GPIO and I found this table, which is awesome. So you can do everything with this. There is a good documentation, and I assume that these are working. So what I did was I connected the ground pin, and the red wire I connected, and both of them are hooked up to the multimeter, and that's what you're seeing on the screen. So what I did was I connected that to this port. So GPIO 108, which is pin 11. So one to the last from the first column, right? So this is it. GPIO 108. So what we can do, if you don't want to write script in Python and everything, I just want to show you a very simple example, right? So right now it's at 3 volt, and that's because that's the I2C bus as well. So what I'm going to do is, here is what you have to do. So first of all, you can do and say 108, right? That's the pin that we need. And echo that into GPIO export, right? So that means that now it's going, the 108 going to be exported now, which we can address it and set the direction and the value. So the next thing is you need to make the direction out, so you can make it output instead of reading, we're writing to that port, and we can set the value to it, and that's going to be the GPIO 108, right? And the direction. Now, as you can see, it already automatically dropped to 0. So now we are at 0 volt because we set it to out, we're not reading, and there is no value, which is 0 volt. So if I do echo 1 to sys class GPIO 108 value, look, it's 3.3 now. And if I echo again and echo 0, watch, and it's 0 now. It's perfect. So I don't know if you watched my hack board video. Well, with the hack board, we couldn't even get this to work. I'm glad that, you know, Asus is not like that, and their documentation is perfect, their example is correct, pins are correct, and everything is working. So I just wanted to show you that. Yeah, that is one thing I wanted to show you. Let me remove these. Another thing I wanted to show you is actually when you are doing like the benchmarks, right? When we are running, let me put this board in the focus. So when you're doing a benchmark, let's say we are benchmarking the GPU or GL mark thing, right? That we had. It doesn't really get hot, and I touched every corner of it. You know, it wasn't hot. As you can see, the heat does not exceed like 37-38 degrees, and that's very good. There is no hot spot. The hottest spot is 40, and it's the same on the other side. So if I hold it and flip it over, right, on this side, that is, hope you can see it on the camera, but yeah, that is still 41, 41.2, something like that. It does not get hot or toasty. Even when you're doing like the yeah, so 44 kind of caps at 44. Let me hold it and flip it over, 44. And on this side, hottest point is 41. Yeah, there is no hot spot. It's spreading the heat properly, doesn't get hot. Yeah, I just wanted to show you that it is the heatsink is more than enough, and just see that the GL mark is running. So yeah, I just wanted to show you that as well. 46 degrees. So long story short, I'm really happy with the purchase. Android one was much better in terms of playback, video, and drivers and everything was very smooth. I installed with the ADB port very easily. Everything was working. In Debian, we have a little bit trouble with the graphics, but the performance is still good. And as you can see, when you run it with the with a software that supports it, you see that you get some good results. GPIO pins are working perfectly. UART, I tried the UART as well. That one is also working. So I'm totally happy with the purchase, and hope you enjoyed my review of this board. If you haven't seen my other videos, go check them out as well, please. There's the hack board and the Chinese motherboard that I got. Anyway, thanks for watching, and I will see you in the next video. Bye for now.